Greetings, my name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Today, we'll explore the foundational skill of multiplication, focusing on real-world applications. We'll also unravel the secrets of the standard algorithm for multiplication. In this animation, I will focus on multiplying single-digit numbers by 2- and 3-digit numbers. We will also look at multiplying two 2-digit numbers. Let's overview the basics of multiplication. First, multiplication is a short way of counting groups of objects. It allows us to count the same number of things added over and over. Multiplication is a math operation that combines two numbers to produce a third number, called the product. This symbol often represents it, though other symbols are also used. In this example, you have 8 items. Add 8 more, then 8 more, 8 more, 8 more, and 8 more. How many items are there in total? There are 48 bears in 6 boxes. Multiplication serves as a shortcut for this process. It's 8 times 6, which is also 48. Let's delve deeper into multiplication by visualizing it as grouping in real-world situations. Let's apply multiplication to a practical situation. Imagine you're a baker preparing cupcakes, requiring 3 cups of flour for each batch. How much flour do you need to make 5 batches of cupcakes? Using the idea of grouping, we can see there are 5 groups, each with 3 cups of flour. We can find this answer several different ways. First, we could add 3 plus 3 plus 3 plus 3 plus 3. We could also skip count 3, 6, 9, 12, and 15. And finally, if we know multiplication facts, 3 times 5 is 15. Another way to think about multiplication is an array. An array is a rectangular arrangement of objects. For example, a 3 by 5 array of flour could look like this. There are a total of 15 cups of flour in the array. The total number of cups of flour is the product of the number of objects in each group and the number of groups. Multiplication is very useful. The most important thing is understanding the basic concept. Multiplication is repeated addition. We often have to multiply larger numbers, and there are many ways to do it. Let's look at some situations requiring us to multiply 1-digit by 2- and 3-digit numbers, or 2-digit by 2-digit numbers. I will use what is often called the standard algorithm because it is efficient. Let's start with 1-digit by 2-digit multiplication, like 3 times 24, as in this example. Suppose you are planning a party for 24 people. You want to serve each person 3 slices of pizza. How many slices of pizza do you need to order? You could count the slices one by one, but a quicker way is to multiply the number of people by the number of slices per person. Again, I will explain the standard algorithm. First, line up your numbers vertically with the 1-digit number on the bottom. We write the operation and draw a line to separate the problem from our work. Now, multiply the 1-digit number, 3, by each digit in the 2-digit number, starting from the right. 3 times 4 is 12. We write the ones position of the answer in the ones position under the problem. However, our answer is a 2-digit number, so we carry the 1 to the tens position. We write the 12 like this. Now we multiply the 3 times the next digit, 2, to get 6. Before we write the answer down, note that we are really multiplying the 3 by 20 because the 2 is in the tens place. We can now write the 6 in the tens position. But wait, we have a 10 that we carried over from multiplying the ones position. Adding these together gives us 7 tens. Therefore, 3 times 24 equals 72. Now you know you need to order 72 slices of pizza for your party. Before moving on, I will check my work with a test of reasonableness. This means asking myself if my answer seems reasonable. 3 times 20 is 60. My answer should be close to 60, but a bit bigger, since 24 is larger than 20. Since my answer is close to what is estimated, it seems reasonable. This is a great way to determine whether your answer is close or seems accurate. Notice that to solve this problem using the standard algorithm, we started by writing our problem in an organized manner. Then we multiplied the single digit by each digit in the multi-digit number. We wrote the answer below. We also carried when there was more than one digit. All large cookies at Joe's Market are currently on sale for $2 each. Rania orders 265 to share with her friends. How much does she spend on cookies? First, write the problem down as 265 cookies times $2. Setting up our problem to use the standard algorithm, I write the 265 on top and 2 below. I add the multiplication symbol and draw a line. Now I begin the multiplication process of multiplying the 2 by each digit in the other number, starting with the ones position. 2 times 5 is 10. I write the 0 below in the ones position and carry the 1. Then 2 times 6 is 12. I add the carried 1 to get 13. I write the 3 in the tens position and must carry the 1. Next, we have 2 times 2, which is 4. I add the 1 I carried from the previous position for a total of 5. This goes in the hundreds position. I have multiplied the 2 by each digit in the other number, so we're done with multiplying. That means Rania spent $530 on cookies for her friends. A test of reasonableness might be using 300 times 2, which is 600. Since 300 is greater than 265, our answer of 600 is a little too big. However, a number smaller than 600 should be reasonable. Our answer of $530 is close enough to know we are most likely correct. Let's tackle 2-digit by 2-digit multiplication, like 23 times 45. Christoph is ordering meals for a get-together. The meals are $23 per person, and he expects 45 people to attend. Let's find his total cost. Again, we start by lining up the numbers vertically. In this case, I wrote the 45 on top and the 23 on the bottom. I also wrote a multiplication symbol and drew a line to separate the problem from my work. We multiply the digits starting from the right. 3 times 5 equals 15. Write down the 5 and carry the 1. Next, 3 times 4 is 12. Add the carried over 1, making it 13. Since I have multiplied the 3 by all the digits in the other number, I write down 13 for an intermediate answer of 135. Then we move on to the next digit in the bottom number, the 2. I repeat the process of multiplying this digit by all the digits in the other number. This next part is important and different than multiplying a number by a single-digit number. Because we are now multiplying by a digit in the tens position, this intermediate answer is 10 times greater than what we get from multiplying the digits. I put a 0 in the ones position to shift all the digits one place to the left and make this intermediate answer 10 times greater. 2 times 5 equals 10. I write the 0 in the tens position and carry the 1. Finally, we multiply 2 times 4, which equals 8. I add in the carried 1 for a total of 9. This intermediate answer is 900. Now that all digits have been multiplied by all other digits, we can get our final answer by adding the intermediate parts together. I'll draw a line and write an addition symbol to remind myself what I did here. Adding the digits in the ones position gives me 5. Adding the values in the tens position gives 3. Adding those in the hundreds position gives 10. There is no need to carry here, so I write the 10 down. Therefore, Christoph spent $1,035 ordering food for his gathering. A test of reasonableness for this problem could be multiplying 20 by 50. This is the same as saying 2 times 10 times 5 times 10. The commutative property shows that this is the same as 2 times 5 times 10 times 10. 2 times 5 is 10, and 10 times 10 times 10 is 1,000. Our answer is close enough to 1,000 to be reasonable. Like before, we multiplied each digit in one number by the digits in the other number. To keep us organized, we lined up the values to start with, then wrote the intermediate solutions so that their place values lined up as well. After each digit in the bottom number is multiplied by the digits in the top number, we wrote down the intermediate answers. As we move along the place value chart when working with the bottom number, we must adjust the intermediate answers. We do this by placing a 0 in the ones position because multiplying by a digit in the tens position becomes 10 times greater. Finally, we add the intermediate answers to get a solution. Claudia is a police officer. She said many people arrested and charged with crimes are frequently charged with multiple violations. Last year, she charged 36 people with 16 crimes each. How many total crimes did she charge the 36 people? First, line up the two numbers. In this case, I wrote 36 on top and 16 on the bottom. I wrote the multiplication symbol and drew a line. Next, multiply the 6 by each digit in the other number. 6 times 6 is 36. Write down the 6 and carry the 3. 6 times 3 is 18. We add in the 3 for a total of 21. We can write this down for an intermediate answer of 216. Then we move to the next digit on the bottom number, the 1. However, because we move to the tens position in the bottom number, we must write a 0 in the ones position. This represents shifting or multiplying by 10. Multiplying 1 and 6 gives a product of 6. Next, we multiply 1 and 3 for a product of 3. I write this down for a second intermediate answer of 360. I can add the intermediate answers since I finished multiplying every digit by every other digit. I will write an addition sign and draw a line to remind myself what was happening. Finally, I add the digits to get the answer of 576. Wow! Claudia charged these criminals with a total of 576 crimes. That's a lot of being bad. Now, imagine if you had to count those one by one. Or imagine adding 36 16 times, or even worse, adding 16 36 times. Multiplication can make repeated addition a lot faster and easier. In my mathematical world, I have one little problem. Multiplication is helpful to calculate how long it takes to travel when you're moving at the same speed. The formula distance equals rate multiplied by time represents this relationship. Please help me understand my vacation. On average, I drive from Savannah to Atlanta at a rate of 62 miles per hour. If I drive for 4 hours, how far do I drive? In Atlanta, I get on an airplane. Most of the time, it travels at 500 miles per hour. I fly for 7 hours to get to Belize City, Belize. How many miles do I travel if the distance equals the rate multiplied by the time? I take a bus for 6 hours deep into the jungle outside the city. The bus driver drives at 56 miles per hour. How far do we drive? There, I go whitewater rafting. The raft moves quickly at 14 miles per hour. How far do we float in 3 hours? Back in Belize City, I boarded a cruise ship. The ship moves at 31 miles per hour, and we go for 39 hours. How many miles did we travel to get to Kingston, Jamaica? Our final destination is New York City, which takes 72 hours. Our ship moves at a rate of 35 miles per hour. How far do we go from Jamaica to New York City? In New York City, I board a plane to return to Savannah, Georgia. The plane flies at a rate of 411 miles per hour for 2 hours. How far will it travel? The airports are 718 miles away by airplane. Did we go far enough, go too far, or the right amount? Represent this using the symbols of less than, greater than, or equal to. Jacksonville, Florida is about 100 miles further. Could we have made it to that airport? Why or why not? Take a look and you will see a mathematical world around you filled with multiplication. As we often need to count many of the same things, multiplication makes this easier than adding the same value repeatedly. The standard algorithm is your trusty tool, whether 1-digit by 2-digit or 2-digit by 2-digit multiplication. Multiplication is a mighty operation used in many different areas of life, from science and engineering to business and finance. We also use it when building things, cooking, and shopping. Remember that multiplication is just a shortcut to repeated addition. So take some time to learn and practice your multiplication facts, and you'll be on your way to success.